This is Big Ideas, Algebra 1, Chapter 6.6. We are dealing with geometric sequences, which are similar to arithmetic sequences. Arithmetic is going to be adding a common difference to each of the terms to get the next one. Geometric is multiplying or dividing, division is a form of multiplication. So multiplying a common number to get your next term. So find the common ratio. The way we find the common ratio is we take the next term, divided by its previous term. So you can do it with this one also. You can take 80, divide by 20, or any term, and divide it by its term before. So it should reduce to the same value each time. And that is your ratio. What would have 320 over 80, which equals 4 also. So we notice that the common ratio is going to be 4. We have negative 72 over 144. We have 36 over negative 72, negative 18 over 36. So what's that, 12 goes into that? No? Well, let's see, that's 9. 9 goes into that, negative 2 times, and is that really half? Oh yeah, half over 4, which equals negative 1/2. So negative 1/2, negative 1/2. So the ratio is negative 1/2. So if we multiply each one of those terms by negative 1/2, we'll get the next term in the sequence. And we can check it, and it looked correct. 84 over 24, 294 over 84, 1029 over 294. I'm going to deal with these little ones right here. So 4 goes into that, 21 times 4 goes in that, 6 times 3 goes into that, 7, 2. So 7/2 looks like it's my number. So what would that be? 42. Divide by 42. Divide by 42. Is that 7? 7 times 2 is 14. Is 28, plus 1 is 29. Yeah, good. So that reduces to, and what's that? 147. Divide by 147, and you get 7. Yep. 49. 7 times 4 is 28, plus 4, 32. 7 plus 3 is 10, so 1029. So the common ratio is going to be 7/2. And that's an important number. So determine whether the sequence is arithmetic, geometric, or neither. So I'm going to take this, I'm going to test for geometric first. So test for geometric, 2.786, 278.6 over 27.86, and 2786 over 278.6. So that's going to be 10, that's going to be 10, and that's going to be 10. So this is going to be geometric sequence, because it has a common ratio. If we multiply each one by 10, we get the next term in the sequence. So that one was pretty good. If I do 71 over 86 and 56 over 71, that's not going to give me the same ratio. Yeah, that's not going to equal 41 over 56. So if and look, here's a nice way using technology. 71 divided by 86 gives me 82558. 58, I think was what it was. 82558. And if I take 56 divided by 71, I'm going to get 07887. 07887. And so these aren't the same, so not geometric. I only have to do the third one, not geometric. Okay, so now I'm going to test for arithmetic. And I'm going to look at the difference. So how do I go from 86 minus 71 gives me 15, and 71 minus 56 is going to give me 15, and 56 minus 41 is going to give me 15. So my difference is arithmetic. Because each term is going to be minus 15, and I can find the next terms in the sequence. Negative 10 over 4, 16 over negative 10, negative 28 over 16. So that's negative 5 halves. This is negative, that's 8 fifths. This is negative 14, 28 over 16, 8, so negative 7 fourths. So not arithmetic. Now I go from 4 minus negative 10, which gives me 4 plus 10, which is 14. So subtract 14 to get this one. That's minus 14. That is plus 26. That's minus 44. So neither. Because there's no pattern, or at least no discernible pattern. Negative 28 over 112, 7 over negative 28, negative 7 fourths over 7. So this is negative, 7 goes into there, 7 goes into 112. 6, 1, 16, divided by 7, 16, 16. So that's negative 1/4. That's negative 1/4. This divided by 7 is negative 7/4 times 1/7, which equals negative 1/4. So arithmetic. Nope, geometric. Hello, geometric. Because it's multiplying by negative 1/4. Right, the next, here's the thing we can remember. So a sub n equals a sub 1 times the ratio to the n minus 1. So next three terms, we don't have to do that, but this will be important for, let's see, we'll see this. So it's negative 12 over negative 2, which equals 6. So if we multiply by 6, multiply by 6, multiply by 6, multiply by 6, so 432 times 6, 2592, negative 2592, next 3 times 6, 1555 2, 1555 2. Let's move those over. Multiply that by 6. This is obnoxious. 93,312. 93,312. So those are the next three terms in the sequence. I may or may not need that little note. So we have 18 over 5 divided by 54 over 25. We have 6 divided by 18 over 5, and then we have 10 divided by 6, which gives us our 5/3. We're going to assume that that's going to be 18/5 divided by 54/25, which is 18/5 times 25/54, and that cancels to 5 and 1. This is, well, that's 1 and 3, so that equals 5/3. Okay, and that should be 5/3 also. So if we multiply 10 times 5/3, we get 50/3. Okay, so we're going back to decimal or fractions, or that is 1, that is 6 2/3. Oh, sorry. Oh, why can't I just do 50/3? Yeah. 6, 10, 16 2/3, either of these, and then multiply that by 5/3. So 50, and that'll be easier if we just do 50/3 times 5/3, which is 250 ninths is the next one, and multiply that by 5/3, which is 125 0 over 27. So those are the three next terms. Yeah, that's fun, right? 6 times 5/3. Yeah, that worked. It's not fun, much like this one's not fun. I think I'm going to multiply it by 1/5. I can already see if I multiply this by, oh no, 5, multiply by 5. If I multiply by 5, multiply that by 5, multiply that by 5, yeah. So I'm multiplying by 5, so the next ones are 15, and 15 times 5 is 25, 75, and multiply that by 5 is 25, and that's 35,405. That seems a little aggressive. No, that's okay. 75 times 5, 375. No, I was wrong. 375. So we can look at them, right? Oh, whoops. Write an annotation equation for the nth term of the GS, and then find A6. Sorry. All right, I did need to find my ratio is 5. So let's go back to that little thing that I saved, remember. So let's take that, and that was actually for this section. So we're going to find the common ratio, which is 5, and we want to write an equation for it. So it's going to be a sub n equals a sub 1, which is 3 over 125, times the ratio, times 5, to the n minus 1. Now we can't simplify that because exponents are going to come before multiplication. So this is the equation, and now if I want to find the 6th term, so if I want to find the 6th term of this sequence, so the 6th term would be a to the 6 is going to equal 3 over 125 times 5 to the 6 minus 1, which is a to the 6 equals 3 over 125. Oh, watch this. I'm going to write that as 5 to the 3rd times 5 to the 5th. Oh, did you see that? I don't need a calculator at the moment. So we have 5 to the 3rd in the denominator, 5 to the 5th in the numerator. So we get a to the 6 equals 3 times 5 squared, which equals 3 times 25, which equals 75. Does that make sense? Might be. I like it. I like how I wrote 125 to 5 to the third. Yes. Yes. Let's go. 1.6 over 0.2 is 16 over 2, which is 8. That's my ratio. We have a to the n equals my first term, 0.2 times 8 to the n minus 1. And I got to find the sixth term, 0.2. Now 0.2 could be 1/5. That doesn't really help me. Yeah, 0.2. I don't think we're going to be able to find any shortcuts. 8 to the 6 minus 1. A to the 6 equals 0.2 times 8 to the 5th. Yeah, that's not a negative exponent. 2 in the denominator, that's 10. Yeah, that doesn't really do anything, right? 2 to the negative 1. 2 to the negative 1 just means 1/5, yeah, 1/2, I mean. All right, so we can't do that. So we're going to do 8 to the 5th, which equals 32,768 times 0.2 times 0.2, 6553, 6553, 8.03, 6553.6 is a to the 6th. The sixth term in the sequence, super fun. 10 through 13, write an equation for the nth term. So the ratio is going to be, what are we doing? We are negative 1/10 or 0.1, negative 0.1, either one's okay. So we have a to the nth equals my first term, which is 2436 times negative 0.1 to the n minus 1. So we'll leave it in decimal form. And we find the sixth term, 2436 times negative 0.1 to the 6 minus 1. A to the 6 equals 2436 times negative 0.1 to the 5th, which will be a negative number with 4 zeros, 4 or 3 zeros. 0.1 negative to the 5th power equals 4 zeros times, well, let's write it, negative 0.00001, I knew it was going to be 4, times 2436. 2436 gives us negative a to the 6 equals 2436 times. So the sixth term in the sequence is negative 0.0246. Okay, great. Well, negative 162 over negative 1458. I don't know what that is. Let's do that. 162 divided by 1458. Negative 1 repeating. All right, so watch this. Negative 0.1 repeating, which is equivalent to negative 1 over 9. Did everybody know that? Don't know if you know you're repeating, because look at this. 1 divided by 9 gives us that. That is knowing 7th grade. They taught you that in 7th grade, by the way. And that was converting irrational numbers or rational numbers, repeating into fractions. So that is going to be my ratio. And we take a sub n equals my first term, which is negative 1,458. And we're going to multiply it by negative 1/9. We must put it in parentheses. And that is that. And a to the 6 equals negative 1,458 times negative 1/9 to the 6 minus 1, which is a to the 6, negative 458 times negative 1/9 to the 5th. That's not negative, that's positive. Sorry. I was thinking, you want to know what I was thinking, is if we have a negative to an even power, then that would be wrong, because that would cancel. And I was thinking, I'm like, oh, odd, all right, well, that's going to end up negative. But that was wrong. It is 1/9. A to the 6 equals negative 1,458. And what is 9 to the 5th? 9 to the 5th power, 59,049. 59,049. I just distributed out that 5, and we get a to the 6 equals 1,458 divided by 59049, which will be a repeating decimal. Negative 0.2. Nope, 0.024694691358, and then it should repeat. 02469. Yeah. How do you like them apples? That is just, that's obnoxious. Does it say to round? Find the a sub 6. I mean, okay, fun. An archery competition begins with 256 competitors after the first round. 1/4 of the competing group remains after the second round. So 1/4 of the now smaller competing group remains. The last round is when there are fewer than 5 members in the competing group. Which round is the last round? Well, so we have 256. Then we're going to divide that by 4. 256 divided by 4 is just like multiplying by 1/4. We get 64. We're going to divide that by 4. We get 16. Divide by 4. And the last round is when there are fewer than 5 members. So after the first round. So first round, second round, third round, fourth round. So which round is the last round? Technically the third round. The last round is when there are fewer than 5. All right, so this is the last round. And there are 4. So fourth round. And there are 4 contestants, competitors. Okay. What is the 10th term of the geometric sequence? Oh, I like this. So they give you the third one. And instead of doing from A to third, so you can reverse. So if we're multiplying to get this, why don't we divide by 2/3 to get that, and that's 8/3 times 3/2, which equals 4. So that's going to be a sub 2, and then we divide that by 2/3, which is multiplying by 3/2, which equals 6 is a sub 1. Yeah, 6 times 2/3. Let's look at that. 6 times 2/3 equals 4, yes. And 4 times 2/3 gives us 8/3. Yes! All right, so we can write a sub n equals my first term, which is 6, times my ratio, 2/3, we need parentheses, n minus 1. So let's take these notes here. Let's grab them, group. Let's make it small. And this is my notes. Good. And so if we want the 10th term, that's going to be 6 times 2/3 to the 10 minus 1, which is a to the 10th equals 6 times 2/3 to the 9th. And a to the 10 equals 6 times 2 to the 9th over 3 to the 9th, which is ugly. A to the 10th equals 6 times 2 to the 9th. I don't want to make it a decimal before. Well, I could, but 2 to the 9th power. Oh, only 512. 512. 3 to the 9th. 3 to the 9th power. 9. Oh, it's a big difference. What? 3 to the 9th. 1968.3. 1968.3. Is that right? Did I do it right? 2 to the 9th power. 512. Wow. That's exponential. Really? That's quite amazing. Just one number. 3 to the 9th power. Yeah. What's 4 to the 9th? See how much that increases. Not that much. 2, well, to the 9th. All right. And then we know that 3 goes into both of those, so 3 goes into that 2 times. And we're going to divide that by 3, which is 2. Divide this by 3. So let's do this. Let's go back to our 3 to the 9th power, and let's divide by 3. Gives us 65, 61. 65, 61, and 512 is not going to be a power of 3 because it's power of 2, prime factorization, because 2 times 2 times a little. So that's going to be 512. That's 10. No, that's 24. 1024 over 6561 will be my 10th term. Now, if I did that as a decimal, let's do this. Watch this. 1024 divided by 6561 gives us a crazy decimal. Yep, we knew that was going to be 1560. That is an irrational, or does it repeat? I don't see where it repeats. I think it's irrational. So 15607 0 1560 7379, I think it was 7692 4249 4. Keep going. Dot. So now let's go back to this. Let's do 2/3 to the 9th. Let's do 2 divided by 3, which equals that, to the 9th power, equals that, times 6, should give us our 0.1560737692424494. Yeah, that's what that fraction is equal to. Yep. And that would be the 10th term in the geometric sequence. Find the sum of the terms of the geometric sequence. Now, I don't know what that's going to be. So we're just multiplying, right? That's a sub 1 is 1. A sub 2 is 1/3. We're dividing by 3. So my ratio is multiplying by 1/3 is 1/9, etc. So the sum of those, I know that it's going to be this, right? We know that it's going to be Euler's number, 1.16, blah, blah. So I know, only reason 689, just through my my just being a nerd, because you're going to get 1/3 plus 1/9 plus 1/27 plus 1 blah, blah, blah. So let's look at summation of sequence. Summation of sequences. What's that formula? Okay, let's look at that. What does that say? So I like that it gave us a formula. Or D, what is D? Oh, difference is 5. Oh, that's a summation. No, that's arithmetic. Oh, no, we need a sum of a geometric sequence. Sorry. Ooh, okay. Okay. Of a geometric sequence. Let's see if this works. Technology. V. I could be wrong. I don't know if it's going to be Euler's, but we'll find it, right? A, where A should be, what, I mean, derivation. Oh, I don't want a video. I don't want a video. Sorry. Here we go. Ooh, nth term, I know that. Sum of it, yes, equals. What is A? I don't understand what A equals. A is my first term. First term, okay. A is my first term. So we'll use that. That's my, well, 1, hello. Okay, so so 1 times R ratio is 1/3. I want an infinite number of terms. I want the sum of all of the terms. That doesn't make sense. Mr. Max trying to, sum of the geometric is nth term, yeah. So, well, okay, but you're not telling me what n, number of terms. What if I want sum of all of them, right? I think, what is the sum of the terms? All the terms? I'm pretty sure it's Euler's number. Terms. The geometric series, sum of terms should be n partial. I don't want m. I want to find all the terms of a geometric sequence. Blah, blah. What is the form? I don't know. I'm pretty sure it's Euler's term. So, oh well. Thanks for staying a little extra. I think that was the last question. Pretty sure it was. Yep. All right. Euler's. Or maybe it's the golden ratio. I'm pretty sure it's Euler because we have the 1 in there. Then we have a fraction. Add up all those fractions.